We are trying to get set up here. How's everybody doing today? It looks like it's just me, myself, and somebody else. Whoever's with me, say hello. Welcome, welcome. Who's here today? I am having some internet problems here. I'm on computer. Maybe because I got so much running at once. Hey, Dimitri, glad to see you here. You're on twice, Mr. Voss Knight. I've decided that I wanted to start sneezing, so I apologize. And I am having internet. I was trying to pull up my Google Drive, and I got kicked off, and just garbage over here. And that's not even where I wanted to be. Did you do the assignment, Dimitri, and how did it go? And what questions are you having so far? What things are going on? Okay. Say hi, Harold, by the way. Hey, Harold. So we are mostly Terra, and we had an assignment. And so let's go back. Which assignment? How about measuring distance in space? Have you had a chance to look at that one yet? It's in Google Classroom. Okay. And so measuring distance in space basically is an assignment where we're talking about how we use light years instead of miles, and to get an idea of how far a light year is. A light year is about 10 trillion kilometers. 10 trillion kilometers. And so that's beyond anything that we can even really comprehend in our brain. And so we generally use light years instead. The other thing that we measure in is something called, so I'm going to type light years in there. Light years equals, you'd see 10 trillion kilometers. Okay. And then the other thing that we use is called an AU, which is an astronomical unit. This is very Earth-centric because an AU, or an astronomical unit, is basically the distance between us and the sun. And it's an average. And I'm going to write that down so you have it there to look at. It averages about 93 million miles, which is about 150 million kilometers. And light travels really fast, right? It takes about 8 minutes for light to get from between 7 and 8, probably closer to 8, from light to get from the sun to the earth. Also, in the time that you clap your hands, light can travel around the earth about 7 times, give or take. That may not be completely accurate, but it's pretty close. At the circumference, the earth is approximately 24,000 miles. And so if you did the math on that, it would be 24,000 times 7. So it's about 168,000 miles per second. I don't know if any of you guys have ever experienced anything like, well, we've all gone and seen fireworks or lightning or something of that sort. Sometimes when we're far away from fireworks or far away from lightning, we see it, then we hear it. We see it, then we hear it. Obviously, that's because the light is traveling a lot quicker than the actual sound. And so sound does travel a lot slower. Speed of sound is only, well, it also depends on weather conditions, but it's only about 700 miles per hour, give or take, depending on temperature and humidity levels. So when light is traveling that quick, we're going to see something before we hear it. We always have that thing where we say, how far away is the lightning? And we're told to count. Not always that accurate, but the idea is for every second, it's about a mile or so. And that again varies depending on temperature and conditions. And I don't know if I haven't paid attention to whether anybody's given us a more accurate reading on that. That's something that's been going around for generations, and I haven't bothered to really think about correcting it. So the assignment that is in your Google Drive, there basically is a chart that you need to fill in and 7 questions. So how would you fill in the chart? You would basically just write the name of the star. Proxima Centauri is our nearest star. And I'm going to spell it here. A-U-R-I. Okay. And so in kilometers, it's actually this far, 43. Anybody want to figure out how much that is? It's probably not worth it, right? And so anytime we have a distance like that, we would take that distance and we would divide it. Here's me not being able to see. I guess we would divide using this, right? We would divide it by 10. Okay. That's not even really accurate. We basically get rid of the trillions, okay? And because that's not going to give us the right answer. 43 divided by 10. We basically, if we did it, what we're doing is we're getting rid of the zeros, okay? And so this is called, why don't I have anything to write with? Oh, here it is. If we had something like this, I'm going to give you the example that's in the book or on the assignment. Okay, you have 25 with 12 zeros after it. So that's thousand, million, billion, trillion, right? So it's 25 trillion kilometers, okay? And basically, if we're going to divide it by a light year, we need to divide by 10 trillion, not 10, but 10 trillion. 10 trillion is going to be this. Okay, that's going to be a similar number underneath it. So what we really can do, the shortcut becomes this: crossing all these numbers off until you have what's left becomes 25 divided by 10. The scientific world, the science, I love you, man. The scientific world uses the metric system, unfortunately, and so even American scientists get adapted to using the metric system. And we are Americans, not English, because the English use the metric system. We're, I think, about the only country in the world that doesn't use the metric system now. And to be honest with you, if you start working on a car, everything are metric anyway. So, yeah, we still teach miles and all our units of measurement that we've grown up with, and yet the world around us is in the metric system. I appreciate your sense of humor. Basically, we can cross these all off and we end up with 25 divided by 10. So if anybody can actually, or 25 over 10, which is the same as 25 divided by 10, if anybody has the ability to do the math on that, so if that star was 25 trillion miles away and a light year is 10 trillion, then we can assume that it is going to be 25 divided by 10. Anybody have an answer for that? You're basically taking 25 divided by 10. Well, there are 12 zeros in a trillion. 3 for 1,000, 6 for a million, 9 for a billion, 12 for a trillion. So there's 12. So, but you got to get rid of all the zeros. You've got 2.5, right? And so when you're dividing, this is a shortcut, right? Because you're dividing 25 trillion by 10 trillion. You can actually just go in and if you write them properly underneath, you can cancel those out and it becomes 25 divided by 10, which equals 2.5. Yeah, and that's the answer. And so when we're looking at, and I'll do the first one for you, which is Proxima Centauri, which I have in there. It's 43 trillion kilometers, and we're going to divide it by 10 trillion, and I'm not going to write it all out, kilometers. So what does it actually become? And I'll write it out on the paper. Remember, that's 12 zeros, 0, 0, 0, 0, 0, 0, 0, 0, 0, divided by 10 trillion, because where are we getting that 10 trillion number? 10 trillion is actually how many kilometers in a light year. So when we have a star that's 43 trillion light years around it, or away from us, we're going to have this formula right here, right? 43 trillion over 10 trillion. If you notice, I got these all lined up, right? So if we just take all of this and eliminate it, then we have 43 over 10. We can eliminate it because our answer is going to be in light years. So the answer is exactly what you said, except it's this. It's instead of 4.3 trillion kilometers, it's 4.3 light years. So make sure whenever you got to remember whenever you're giving an answer, just like that 2.5 or that 4.3, make sure you're saying it's light years. It's what are you measuring? The other thing that we could measure, and that's going to be the assignment, if I can find it on my jump drive, is using AUs or astronomical units to measure too. So remember, an astronomical unit, I have it in there, it's approximately, the average is 93 million miles is what we use. So how many zeros are in a million miles? 1,000 would be 3 zeros. Million would be 6 zeros. So that's 93 million miles. That's 6 zeros. That's right. So an AU is 93 million miles, right? It helps to put the commas in there. You can see it better. And so the other assignment that I have is going to be doing basically the same thing, where you're measuring distance between planets. And so if we have Jupiter, Jupiter is one distance, and so we're going to take Jupiter's distance, and let me see if I can pull up that sheet using the wrong. Boom, 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 boom. All right. So Jupiter is 483 million miles. 483.8 million miles. Okay, how would we write that? We would write 483, comma, 800. That's the 0.8, 000. Jupiter from Sun, right? Okay. How do we figure out how far Jupiter is from us? Not from the Sun, from us. Well, first of all, in AUs, in astronomical units, first of all, we would want to take that number and divide it by an astronomical unit, which is this, right? So we're going to take that, and so you can do this with the planets, right? 483, 800, 000, and throw that over 93, 000, 000. Okay, and you get a formula, and I'm scribbling, that looks like this, right? 483, 800,000, 000 over 93 million. Okay, and I scribbled that. My 4 actually looks like an N. But here's the deal. Again, we can start crossing stuff off, right? And so it actually becomes, the formula would become 483.8 divided by 93. Okay, we take that 483, we get rid of any zeros that we have in common, okay, and it becomes 483.8 divided by 93. And so if you have a calculator that you can do that, 483.8 divided by 93, you're going to get an answer. Oh, in astronomical units, by the way, you can put AU, or so it ends up being this 483.8 divided by 93 equals. So did you come up with anything? 483.8 divided by 93. And we should have come up with, let me see, 483. $4.34. That 4.3419 AU. All right. How did you get to your math? Hello. How did you get to that number? You should have, we actually, you can do it beforehand or afterhand. I think what you did is, did you already subtract, did you subtract the distance from Earth too? I used a calculator. So I came up with a different answer. Okay, so 483.8 million miles from the sun. We should have used kilometers, but here we are. So you came up with 483.8 and divided by 93. See, I came up with 5.2. 483.8 divided by, and I have a comma in there, so that's actually wrong. Hold on a second, let me fix this. And I didn't even send this to you. 483.8 divided by 93. All right, so yeah, I may have inadvertently said something different, and I apologize if I did. But you have 483.8 miles divided by 93 million miles. That would give you 5.2 if you did it the same way I did. Okay, and I'm going to put that answer because come on. So I don't know why my period is coming through as I guess I'm pushing the wrong button. All righty, garbage in, garbage out. So that's how far Jupiter is from the sun. But we forget something. We're 1 AU from the sun. So then you would actually have to take 5.2 AU, right, minus 1 AU, and that would equal 4.2 AUs from what? From Earth. So the question was, how far is Jupiter from us, not from the sun? And so, yeah, that's why I was questioning that 4.3 that you got. I was like, that's pretty close to what we're going to end up with. And I wasn't sure how you got there. Anyways, we are over on our time because Ms. Miller has to be broadcasting. I believe she squeezes right after me, 1, 2, 3. And so we are going to be leaving. Don't forget, you can email me, and I know you guys have. You can email me. You can send me messages in Google Classroom. Make sure you're getting onto Google Classroom and getting these assignments done. And I hope you guys are having a great day. I was answering emails up until about 11 o'clock last night, and so don't hesitate. And please, 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 if I know you're friends with other people in this class that I have not seen, we need to start communicating with other 6th graders and get them on. We're done as far as now till the end of May, or to the beginning of May, rather. We're going to be home through April, so you guys need to be getting on. See you on Thursday. Say goodbye, Harold.